Here are 3 furnaces, each with a separate circuit. I'm going to be splitting them up into 3 different videos. The furnace is the simplest, just using a mechanical flasher. Then a little bit more complex is a blast furnace, which uses transistors. And then finally, the most complex is a smoker, which uses a 555 timer alongside a comparator. Sorry about my hands. I was in a lethal fight with a mountain lion. Anyway, so here's a furnace. The way it works is there's this little stake piece that has copper foil tape, and that goes inside to some contacts and allows the circuit to flow. Here's a mechanical flasher I'm using off of some Christmas lights. The way it works is there's this long piece of steel that flexes when it gets heated up. And so that piece is connected to the filament here that creates the light when amperage goes through. And so when this metal cools down, it will bend to this lead over here and allow the circuit to be complete and flow through the filament. As the metal heats up, then it will bend back over here, disconnecting this lead. Over time, some of the metal gets heated up and evaporates off. And so the loss of metal will affect this bend. And so it will either bend it off of the lead or bend it onto the lead even more. Here's an example of it being bent off of the lead. And so you can see a tiny gap between the middle lead and the right lead. Now a light bulb still works, and I can show that by using a magnet to force that middle lead back onto the other lead to complete the circuit. And if I hold it, it will actually disconnect it, since the middle lead is able to still bend the other way. There's another case where the middle lead bends the other way, forcing it to always be on. And so in this case, I'm not actually able to force it back off. And it might be because it's welded on to the other lead, or I just don't have a powerful enough magnet. Here I have another flasher, and this one is for a turn signal from a car. The way the flasher works is there's a coil of this wire with a specific resistance that heats up. And as it heats up, it allows this tension in this wire here to either be reduced or to increase, depending if it's heating or cooling. This turn signal is pretty slick because it's actually using this tension here in the wire that's being heated. And so when it cools down, it's actually tensioning up, which connects this contact. So instead of bending this plate here through heat, it's actually bending it through tension. Now I'm using a power supply which automatically limits the amperage by reducing the voltage. So what's affecting the timing of the flasher is actually how much amperage is going through. So if I reduce the amount of amperage that's able to go through, you see lowering it will slow it down. And that brings up a big issue with these types of flashers that require a lot of amperage to flow through. If you're powering something that only uses a small amount of amperage, then that amperage is not enough to effectively heat it up. And so it takes a while for it to lose this tension. And so here I have a relay, and the relay only uses a small amount of amperage. And so if I disconnect the ground and now hook up the relay turns on, but the amount of amperage going through this coil wire is only 0.13 amps. And that's not enough to effectively heat this up so that it can disconnect. Despite its drawbacks, it's really the simplest way to create a flashing circuit without using any complex electronic parts. So here's a circuit, and it's using this Christmas light flasher. Right now it's using a coin cell battery, and as you can see, it's starting to fade down because the battery is not powerful enough to power the circuit. What's happening is a lot of amperage is trying to flow through this Christmas light as well as the LED, and the battery's not able to supply that. So the battery right now is actually dropping in voltage. And so that drop in voltage is no longer able to supply enough voltage in order for the LED to allow current to flow through. Now by supplying 3 volts directly to the circuit, you can see that both the Christmas light and the LED turn on. So as long as the power source is able to supply that amperage, then both lights can be on at the same time. I soldered this plate on in order for it to not move. Inside I have 2 tabs from the plate which are bent out, and the copper foil tape is connected to those and allows the current to flow through once something is put in between those tabs. So here's a steak up close, and there's just copper foil tape right there alongside the edge as well. And on the other side I painted a different color to show it's cooked. Also I have a pork chop here. So So it's pink. Again, you can see the copper foil tape a lot more clear here, and then more along the side. In order to make the window, I just used resin with some tape in order to hold everything into place. So that's pretty much it. If you have any questions, please let me know, and thank you for watching.